Welcome to VBar 101. I'm Fredrik Mellin, aka Mr. Mel. Today I'm gonna go over step by step how we set up an electric governor. For this session I'm gonna use the throttle curve as my control for the governor. Every radio can control throttle curve, so in that way it's simple to use it. If you have a separate receiver like this one, you need to run one cable between throttle and the aux on the VBar. If you have a spectrum, you need to make sure that channel 1 is in the ESC throttle, Futabytes number 3.
If you watch the setup step by step with a separate receiver, this is familiar to you. With electrics, we only use one channel for controlling the governor, but we don't use that stick to spool up. We only have motor off, governor off, without that stick control. So when we drag the slider or the throttle channel in the case, everything below 0 or first half is motor off and the governor is off. It's when we go over this center, then it translates to a head speed, and the maximum head speed setting in the VBar is what you get at 100%, so in my case here 1910, and everything below this is a head speed. That's why in idle up 1 and 2 you should use a flat curve. However, if we enable the auto rotation bailout mode and go down, that will mean motor is now off, bailout is arm. If I flip out of that hole, it will faster spool up to the head speed again. But if I go down to the far end, to the bottom, then motor is off, governor is off, bailout is not active, meaning we get a slow start. So this is the concept of how one channel can control everything, and this will help. If you understand this, that will help you in a great way when setting up the governor. One thing that throws people a little bit off base is the definition in VBar of a signal and its level, because in the VBar it says from -100, then center is 0, then you have +100. It might be that it translates in your radio to 0, 50 and 100. It's the same thing, it's just different definitions of the signal. Some radios actually have from -100 to +100, but when you activate a certain function it might be 0, 50, 100. So you need to keep track of this, and if I'm at 0 and saying you need to go lower, that number might be -100. If I say -50 and you need to raise that number, I probably should say go closer to -100 or to make it easier. But keep in mind that this type of definition and this type of conversion that actually happens, so you know where you're at. So in your 0 to 50 curve might be in the program same as -100 to 0.
Then I go over to transmitter mode, and I need to make sure that my throttle is calibrated from -100 to +100. So what I'm going to do is disconnect the motor here and make sure I have 100 and 100. Also make sure the collective is reading the same thing, because we will need that collective channel. So when I'm done with that, I go over to Governor 1 page, select electric and press reset. Then here it should read that channel I dedicated my throttle channel, and in this case it's channel 1, so that's correct, and I can see -100. Then I should select output to collective. Important, run a separate motor like I do here, or back off the pinion, because there is a risk of something spooling up and it could get hairy very fast. In this case I'm running a motor, speed controller is connected to the ESC port, and I have a Hyperion phase sensor connected to the sensor port. Now we need to set the endpoints for this speed controller. Doing that, we can try to do it. There is two ways. Either you do it by trying to figure out the beeps and when it arms and stuff like that. It could be a little problematic because if you have a built-in BAC in the speed controller, when you unplug it and plug it in back in, then the VBar is reset, so you actually disable that mode in the setup mode in the VBar, so then you have to run an external power. So the way I've been doing it is backing off the motor or having a separate motor like this. Then when I press on here, I will transfer the control to the pitch curve. It's direct control over the motor via the pitch curve now. And to make that work, I need to make sure I have a 0 to 100 pitch curve in the radio as well. What I'm doing now is I'm dragging the lower endpoint until the motor starts, then I back off until it stops again, then I know my limit. So around 90. Now I can either come to the conclusion that, well, it's probably gonna be 90 on the upper side as well, and just set 90, or I can test that by going full throttle and lower the slider until I hear the motor change in RPM and then go up a little bit. So let's test that one. Quite high sound on that, bearings are gone. It ended up as 90 as well in that. So now my speed controller is calibrated against the governor. Then I can disable this setup mode. Now I have a couple of things I need to set. First of all, maximum head speed. Remember where I told you that the percentage in the radio translates to a head speed where 100% is a head speed, and this is the maximum. This is where 100% is at. So 2200 is good for me. Then I need to set the gear ratio for my helicopter, whatever that might be. Let's say it's 10 for this one. Then one important thing, and that's if you're using these phase sensors, you need to enter a number to divide by the number of pole pairs. This is a 10 pole motor. In this case with Hyperion sensor, this might change depending on which sensor you're using. But for the Hyperion I need to enter 5, meaning it's 5 pole pairs in this motor. So enter 5 and then OK. Then we have the auto rotation bailout mode, and as I showed in the earlier video clip, that can be enabled so you can get faster out of auto rotation. What I have done now is completed the basic setup. With an electric, I like to test this on the bench, making sure that the sensor reading correctly, and since I can spool this up here, it's no problem. So with electrics, when I've calibrated the endpoints like I did motor running and use the slider, there is one setting I have to change before testing anything, and that's the percent minimum governor. First of all, I should press electric, then I need to set this to -70. It might be that I need -75 if it overspeeds. This setting tells how low is the governor allowed to go on the throttle range. So then I want to see if this setup actually working. Now I haven't programmed any curves or anything yet. It's just for testing purposes. So when I move the stick down here, nothing happens. Everything is off like we said before. But when I go over 50%, it will spool up. So now it's just a test to see that everything is working correctly. The motor spools up. And that worked, and you saw it stabilize. You heard it actually surging. That depends on, this is not a correct setup. It's really not optimal for that type of RPM I'm running. So that's why it wants to be somewhere around 2700, and I'm trying to run it as low as possible so you can hear what I say here. So that's why it's surging. Now it's tested, so I know it works, everything works. Then I want to go back in setup and go into Governor 2 and program my curves. So how should I program the curve? Well, my hold is 0%. That meaning motor off. And you can see this in the program. You can see this by requested RPM is 0, and if you go back to Governor 1 page, it's -100 here. Then it's a preference. When you flip out the hold into normal mode, you could have a flat curve that that translates to a head speed, but I actually have one very steep. So I have 0 down here, then I go up here, and it translates to 80% here. Going over to Governor 2 page, it translates to a head speed here. Then my following idle up 1 translates to another head speed, and idle up 2 translates to my maximum head speed at 100%. And you can see this in Governor 1 page. You can see actually 101, and it changes, and throttle hold, then it's -100. So the curves are now set up. It's important to use flat curves, because if any change in the curve when it's above that Governor active line, then it will translate to a change in head speed. Finally, going out here to the main screen, this curve should look like this. It's the fail-safe curve in case of sensor failure. That's your backup curve. So it's important that that's correctly set, and it's default when you press the electric button.